This lesson we're going to look at advanced factoring. So this is just actually a little bit kind of like an extension of the factoring you've done already. It's also going to kind of review all that factoring. So the first type of factoring we're going to look at is something called U-Substitution. U-Substitution is actually a pretty important idea when you do something called integrals in calculus. So this is the first time you're looking at, we're using it in a different way though. So it says you will be given a polynomial in the form of a factorable quadratic a u squared plus bu plus c, where u can be any function of x. You may be asked to factor such an expression or to solve an equation for x. So that sounds confusing. I'm going to look down at a problem first. So this is our first one we're going to look at. So what they mean is there's actually no a in this one, right? There's nothing in front, but we have something squared, okay, minus 2 times that same something minus 35. So we have some function, in this case x squared minus 9, and then it's squared. Then we have, in this case, our b is a 2, right, times that same function, x squared minus 9. And then in this case, our c is a 35. So here's our steps and what we're going to do, and we'll do 2, and I think after the second one you'll probably catch on. So the first thing we do is determine the function of x and set u equal to that function. So the thing that's being squared and then by itself in the second time is x squared minus 9. So we're going to say u equals x squared minus 9. Then we're going to substitute u into this equation. So we have u squared minus 2u minus 35 equals 0 because we're plugging u's in for all the x squared minus 9's. Now, we should have something pretty easy to factor now. So we're trying trinomial, pretend their x is not u's. We use a different letter because the x is already in the x squared minus 9, if you were wondering about that. U is just this chosen letter that we use for substitution in math. So numbers that add up to negative 2 and multiply to negative 35, that would be negative 7 and positive 5. Now, there's different ways to do this, but I find at this level the best success happens when right after we factor, we just plug back in the values of u. So going in for u, instead of u, I'm going to bring back the x squared minus 9. So for every u, I'm plugging in x squared minus 9. I'm just going to put in parentheses. It doesn't matter in this problem, but it does sometimes matter. So I'm going to write down the rest of this. We have a 0. Come on, pen. There we go. So we're plugging in that x squared minus 9 for the u's. Now we're going to simplify. So as I said, the parentheses don't really matter. I have x squared minus 9 minus 7. So this one is going to become x squared minus 16. When I combine the negative 9 and the 7, no distribution. There's, the negative 7 is a minus 7, not times negative 7. And then the second one, x squared minus 9 plus 5, so that's x squared minus 4. So far we substituted the given a function of x back in for u, and then we're going to factor again if possible, or solve for x if it's an equation. So since I'm solving for x, I could factor each of these, but I'm just going to use incomplete quadratics. So I'm going to set each of these factors equal to 0. We're trying to solve because we have an equation, and that's what the directions also say to do. So this one I get x squared equals 16, which if I take a square root is going to give me x equals plus or minus 4. This one gives me x squared equals 4. And if I take a square root, I get x equals plus or minus 2. So now it doesn't look like it, but in the beginning, if we had done the simplification, we have an x squared squared, which means this is a quartic equation, x to the 4th. So it makes sense that we have 4 roots. I could write them together, negative 4, negative 2, 2, and 4 if I would like, but you can also just circle the values of x. Looking at the next one, we'll talk about what we would do on this one. First off, it's just a factoring question. So once I get it fully factored, I'm done. I don't have to solve and get x equals. I see kind of a similar setup where we have something squared minus, in this case, 5 times that same something minus 6. So this is our opportunity to use U-substitution. We're going to make our u 4x squared plus 5x. So my function is u squared minus 5u minus 6. Looking at numbers that add up to -5 and multiply to -6. 6 is our tricky number. Sometimes we mess it up and pick the wrong ones. It is not a 2 and a 5 or a 2 and a 3 because that would not work correctly if you try to, both of them negative wouldn't multiply to -6. One of each wouldn't add up to -5. So the correct factors are -6 and +1. Right after factoring, I'm going to bring back in my values for u. So I'm going to need to leave some space here. I'm going to write what I currently have, and then I will write in that value of u plugged back in. I really see I don't need parentheses on this one, so I'm just going to leave it like that. Now, we have kind of just begun in terms of how long this problem is going to be, because I noticed that both of these, I might be able to do that rainbow and then split the middle. So I'm just going to try that here. So I'm looking for factors of -24 that add up to 5. I do have those. That would be +8 and -3. So I'm splitting up my 5x into 8x and -3x. And then I'm going to group. I'm just going to finish this side first. Hopefully I don't forget there's another side. That's just something to be careful of. And I'm not explaining the factoring too much. Basically, we're grouping, right? And then we're going to finish it off. So my common factor is x plus 2. And then I have 4x minus 3. Moving over to the other side, we want factors of 4 that add up to 5. So this one is +4 plus 1. 1 times 4 is 4, sorry. 1 times 4 is 4, and 1 plus 4 is 5. So underline here, we take out a 4x, and we have x plus 1. We take out a 1, and we have x plus 1. And moving on from there, we take out the x plus 1, and then we have a 4x plus 1. Checking back, just in case I didn't lose an equation, I didn't have an equation to start with. It just says to factor. So this is my final answer.